Hello and welcome to CS264 Software Design. This is lecture 20, working with software design patterns, structural patterns. This is a pre-recorded lecture and we're going to specifically look at the bridge pattern and we can see how it might be implemented in C#. Okay, once again, as I mentioned in the last few lectures, most of my examples and references will be taken from this book, Dive into Design Patterns by Alexander Svets. It's a great book, it's a great website, and please use it for the examples, especially for the design patterns that I have mentioned but not covered. The book and the website gives great overviews, lots of examples. It gives demo programs in C#, Java, C++, lots of examples. Definitely worthwhile checking out, and I certainly recommend getting the book as well because it's nice to have everything in one place. So you don't just have to look at the web the whole time. Okay, so we're working with structural software design patterns in this lecture, just as we were in lecture 19. And you may remember in lecture 19 that I talked about the adapter pattern, and I also said, that there's sometimes you want to use bridge, sometimes you want to use adapter. So I thought it would be a good idea to go into bridge in a little bit more detail. Of course, all of the structure software design patterns are concerned with describing how objects and classes can be combined to form larger structures. Easier design identify simple ways in which to realize relationships between all the entities or objects and classes. And we saw already that there were 7 of these patterns, adapter, bridge being the first 2 we tend to recognize, composite, decorator, facade, flyweight, and proxy are the remainder. I talked a little bit about how useful it is to build proxies as well, especially if you're trying to connect to hardware or to remote objects and so forth. If you think back to proxy, you think back to your web development, a lot of the time when we build RESTful APIs, we're essentially building this proxy around some service that's available to us as well. So the pattern is a deployment pattern in many respects as well as a design pattern. And again, all of these patterns are designed by considering the class's structure and composition. And the goal of the structural design patterns is to increase the functionality of the class or the classes involved without significantly changing the composition of the classes. We don't want to be making changes. We don't want to be updating classes at all. We want augmenting them in some way. As you say, there's a difference, and you've seen from the last lecture, difference between the creational design patterns and these are all about instantiation of objects. They're different from the behavioral patterns. We haven't seen this in detail yet, but they're designed around class communication with other classes, and the structure, of course, we saw last time with adapter. Really nice. Okay. Well, this time we're going to work with bridge, okay? And again, we can use either the reference text here or the UML diagram that I'm using here has been taken from gofpatterns.com. So you can check gofpatterns.com and look up the bridge pattern. You can look at the bridge design patterns that are available on Refactor and refactoring.guru, that design patterns bridge as well. Lots and lots of them. Okay, so the bridge pattern, rather than patterns, I suppose. Let's go and fix this while I'm here. Okay, this bridge pattern, it's a structural design pattern, again, as we know already, that lets you split a large class or a set of closely related classes into 2 separate hierarchies, an abstraction hierarchy and an implementation hierarchy. So that's important here. We take a large class and we split it into 2 separate hierarchies. Each hierarchy can be developed independently of each other. That's a nice definition from the Dive into Design Patterns book. The GOF patterns definition tells us that we divide a complex component into 2 separate but related inheritance hierarchies, a refined abstraction and an implementer, which is an abstract class that inherits classes. For example, some concrete implementer A and B. So this is from the GOF patterns reference. So we're seeing the same thing but referenced in a couple of different ways, and I certainly recommend you do some searching through maybe some other examples. You may find some better books or something, but find a definition that works for you. I do like the first one here, and I like this one, the second, and I think they complement each other well. What I like about the second one from the GUF patterns is that it tends to relate very specifically with the UML diagram for the bridge pattern. Okay, and we can see that here. We can see that we have the abstraction here, which is nice and it's defined here, and we have the implementer, which is here. Okay, implementer. Now remember, the bridge pattern is done a priori. It's developed first. Okay, so we look at the bridge, we look at our designs before we deploy. Okay, it's different to the adapter, which we saw last time, which works with classes or objects or services that exist and we cannot change. I know in the example with the plugs and so forth that we had, we were writing that class as well, but that was just for illustrative purposes only. But this is an interesting one, because we do this first. So we talk initially about the abstraction that we have, and we have some operation here, and then we can refine that abstraction there, of course. Then we have some implementer, which implements the operations. We have many operations here. This is just lets us know this is an abstract class that ultimately needs to be refined in some respects in order to be instantiated, a concrete instantiation of this abstraction. We can have many methods here, okay, or we can have fields in here as well if we wish, but we're not using that. Then we have the implementation here, and then we have concrete implementations as well as this. So I'm going to look at this one a little bit later in this lecture to tell you about how you can use this, for example, for adding color information to shapes, for example. I'm sure you're doing this already, but we can see this composition type notation here as well. So it's a useful way to have this. So what I'm trying to do in this one, I guess, this lecture is to show you various versions of the bridge pattern as they appear in all of the various kinds of literature. But this pattern here is fairly standard. Okay. So this is a slightly different version of it, but it's pretty much, we can flick back between the two diagrams. We can see we have abstraction or implementation, concrete implementations, abstraction, implementation. Here's some concrete implementator. This just refers to two of them, of course, but we might want to do this when we have many rather than just two. Okay, and then we have a refined abstraction and a refined abstraction. So all of these work together. This one, of course, is from the bridge design pattern examples under refactoring.guru website, and you can see that here's the bridge. Okay, this is the bridge. If you're wondering about where the bridge is, this is it. The client has this bridge. Okay, and the bridge essentially, why is it called a bridge? Because it's the bridges between two sides. Okay, so remember we broke the pattern into two, the abstraction and the implementer, and that became the bridge. Okay. Okay, so we use the bridge pattern then. When do we use it? Okay, and we asked these questions last time as well. We talk about the two ways we think about using structural patterns. What do? We learn the patterns, we understand all the patterns, and we have that in mind when we go and build something. There's a lot of patterns to keep in mind, and then there's, they tend to be abstractions in themselves, so that might make it a little bit difficult for us. And the other way to think about it is, we'll say, well, let's look at some concrete examples of things we might want to do when we write software, design software. In this case, we're looking at design, very much looking at design. And we have this in mind and we say, well, I want to do this. What patterns apply? Okay. So, something useful that you can understand. And it's again, this is not so that you memorize all the ways in which you use bridge. You're meant to, or I expect you to take what you learn from this and apply it in general to other patterns. So you need to generalize, abstract in many ways from what's been said here. Understand scenarios, and then what patterns are useful in those scenarios. That will stand to you in the long term. Okay, so when would you use the bridge? Right, well, when you want to avoid a permanent binding between an abstraction and its implementation. Okay, we don't have that permanent binding here. When both the abstractions and their implementation should be extensible using subclasses like we have here. Okay, and changes in the implementation of an abstraction should have no impact on clients. Okay, so when you want the implementation here, you can do all your changes here. It won't change this section, this side of the bridge at all. Okay. In other words, you shouldn't have to recompile this code. You're only compiling the code that's necessary. And I know you probably, when you go to your .NET, environment, or when you're using Java, you can see what needs to be compiled and what doesn't need to be compiled. But you're dealing with a few classes, maybe 2 or 3 classes. But if you're dealing with situations where you've got large classes, large amounts of classes, or both, in fact, then you want to recompile, and compilation can take a long time, hours, for example. But you want to cut down on that recompile time, or you might want to patch something by replacing a class. So you might want to replace the .java, the .class file, for example, that's generated. If you're working with Java, you don't want to be compiling everything. You just want to be able to replace the class. Programs should still work. Okay. So this is when you start thinking about using bridges. This enables you to separate the interface from the implementation. This is the interface, and improve the extensibility. Okay, and then also hide implementation details and clients. You want to hide this. You might have proprietary stuff going on in here in these concrete implementations that you want to hide and just distribute the class. You could obfuscate the class as well, so that it can't be reverse engineered to see what actually is going on. But you could, you share this piece here. Okay, and that's a useful thing that you want to be able to do. Okay, so maybe let's have a quick look at what's happening here. So the abstraction here, that provides high-level control logic, and it relies on the implementation object to do the actual low-level work. Okay, these are the concrete implementations here. Okay, the implementation, that declares the interface that's common for all of the concrete implementations. An abstraction can only communicate with an implementation an object via the methods that are declared here. Okay, so that's all. Okay, the abstraction may list the same methods as implementation, but usually the abstraction declares some complex behaviors that rely on a wide variety of primitive operations declared by the implementation, as described in detail in this text here, of course, as well. Okay, here are the concrete implementations. They contain all the platform-specific code, or the very specific things you want to do. The refined abstractions, so classes basically. They provide variants of the control logic, like the parent. They work with different implementations via the general implementation interface, and then usually the client is the only one interested in working with the abstraction. The client's job was to link the abstraction object with one of the implementation objects. One of these with one of these. Okay. This is an isolated image from a large description that's here. So you click through here, you'll see this pattern in detail on it, and it's really nice to go through those at your leisure. Okay, so yet another description here. Okay, again, did I do this? No, I didn't think I generated this one. Okay, it's also probably from another of the refactoring.guru websites. Yes, that's where it came from. Okay, again, you have your client utilizing this interface, specialization of the interface, and then again we have that separation. The bridge is here where we have the actual implementation. So what's happening here is we have this decoupling of the abstraction from its implementation so that they can vary independently. Okay. Remember, in the last lecture, we talked about the adapter pattern, and the adapter pattern makes things work after they've been designed, and the bridge makes them work before they're designed. Okay. So the bridge is a design strategy here. Okay. So the bridge is designed upfront to let the abstraction and the implementation vary independently, and the adapter is retrofitted to make unrelated classes work together. Okay. So a nice example that I thought, which I liked, that came in the refactoring.guru website. It was an example of something that we might be interested in looking at, and it's a good example because you've had lots of assignments to do with shapes and colors and all sorts of things to do with shapes really for the past 10 weeks, and really what we're interested in doing is looking at exactly what the current assignment 5 is exactly what's described here in this particular book and in the on the website. So let's say we have a geometric shape class with a pair of subclasses, circle and square, and then we want to extend the class hierarchy to incorporate colors. Now, I think for some of the earlier lectures last time, I think when we were looking at structural patterns, we were talking about when we were talking about the creation of patterns, we were talking about rounded and regular shapes, for example. as we didn't talk about colors at that point, but we might want to have rounded shapes, regular shapes, colored shapes, and all that kind of stuff for our drawing application. Okay, but we plan anyway in order to have creation of red and blue shape subclasses. So we have a red circle, red square, blue circle, blue square, all extending here. I know many of you are not doing this, okay, but why are you not doing that? And you need to be able to reflect and say, well, this was a good design. And I often say, to students, well, that actually is a good design. Why did you do it that way? And they say, well, it just seemed like a good idea. Or it was kind of like a naturally good design based on your experience. Well, they couldn't prove to me or tell me why this is a good idea. So I think this is what's important is you go back and, you look at your code and say, well, yeah, I did a good job here. Okay. And instead of just saying, well, I did a good job and it works really well, you can now say, well, actually, I implemented a bridge pattern here. Okay. And that's why it works. And then all of the advantages, and perhaps the disadvantages of the bridge will become apparent. And it helps when you're explaining or describing your code, or sharing your code with other developers. Okay. So let's say we have our blue and red shape subclasses. Okay. That means that because we have two shapes and two colors, we're going to end up having four subclasses. So a bad design, in many respects, would be, if we continue to have all of these, then the more shapes we have, the more colors we have, huge numbers of subclasses. Okay, it might seem obvious, but it's worthwhile actually saying it. And what we're saying really is that adding new shape types and colors to the hierarchy is going to result in some exponential growth. So for example, if we wanted to add a triangle shape, then you'd need to introduce two further subclasses, one for each color. Adding a new color will require creating three subclasses, one for each shape type. Now, the further we go, the worse it becomes. And then let's say we actually wanted to have red circles, well, not red, let's say we wanted red squares with rounded corners, or red or blue triangles, or green triangles with rounded corners, or we wanted to have like dashed lines as borders. Then all that style aspect that we have, and I know that you've been working with styles in your assignments as well, then suddenly it becomes much, much more complex. So we need a better way to do all this and a better way to design. So really what we want to be able to do here is, the problem is that we're extending here. It's got to do with this subclassing. We want to try to avoid the subclassing if we can. And so the problem happens is because we're extending the shape class into two independent dimensions by form and by color. And that's a common issue with class inheritance. Okay. So this is better. Okay. So we can extract the color related code into its own class with its own subclasses. So we have shape and actually it's shape and color here. That's what happens with copying and pasting. The shape class contains a reference field pointing to one of the color objects. Okay, it's containment here. So the shape object can delegate any color related functionality to the linked color object. Okay, in other words, it's a reference. Okay, and this reference will then act as a bridge between the shape and the color classes. So additional colors will not require changing the shape hierarchy and vice versa. Okay, and you could actually think in terms of style here. I mean, personally, I would think that because we have color, line color, border thickness, all of these information that we want to have, we could actually delegate this to style rather than just color. So you could generalize this as you could for your assignments. So if you actually check the link in the refactoring.guru website, they don't give an actual example of how to implement this in code, but there is a really nice example on device remote controls, for example, where you can use a bridge in that example. So it's another example that's not the same as the one you're looking at, or the one you might be interested in for your assignments, but it's a really good and complete and short example. So I'd recommend clicking through here, okay, and you'll see another example. So what do we do about this example here? Well, I decided it would be a good idea maybe just to write it myself for you. Okay, so we could design and implement this example then. So what I'm doing is I'm kind of going through the process now that you would like to go through when you want to start looking at using and building bridge. Because remember, bridge happens first, okay, in terms of designs of our classes. We think about the bridge. And we go through these steps, and these steps are really nicely described in the textbook as well. So, and in other places, of course, So we could design anyway this color example using colored shapes and the bridge pattern, following the guidelines. Okay, so there are guidelines in the book, guidelines on the website, guidelines on another website, and we're basically saying we're working through this here. So we take the UML pattern because this is our guideline. Okay, so here our abstraction. Okay, that could be a shape class. Okay, maybe it might be a nice idea for something clashed. Look at this. We really don't want to have Java doing things like this for us. Okay, so let's correct this. Okay, so here abstraction, that could be shape. Okay. Concrete extraction, here that could be circle or square or triangle or anything we've seen before. Func could just be something that they do. Okay, so draw or get the color or any of the concrete things we want to be able to do with our shapes. Okay. Now it also contains then this implementation. We have this imp here. Okay, that implementer is of type implementer, so that could be a color. And that could be the color of this particular shape or in this concrete instantiation here. So our implementer, you can see it's an abstract class here as well. And really that then could be color, okay, or style, any of those things. Could be some drawing API, could be any of that sort of stuff. And in concrete implementer, that could be blue color or red colors. So this is how we might look at the bridge. So this is one side of the bridge, this is the other side of the bridge, the abstraction and the implementation, okay? And this is how we might work at doing this. So yeah, so we could change it then. And so then here we then, as we said, then shape is, look at the autocorrect that's going on here. Let's fix this autocorrect. Yeah, let's fix that autocorrect. Let's fix the autocorrect here. You make slides, and this is what happens. Okay, so we have our, so this looks nice now. Okay, so we have this shape class, that's the abstraction, and it has some mechanism to manage the filling the shapes and colors. That's color, which is basically, you see it's protected or it's private here, and it contains that information, which is of type color. And then we have a red color and a blue color, which are instantiations of this, and whatever we need to do. There's the implementation of the interface method here. Okay, and again, we have methods associated with these classes here, which are concrete classes of shape. Okay, and they in turn will use the mechanism made available here, color, to access this color information. And then so red color and blue color, they're just concrete implementations in the abstraction hierarchy. Okay, so actually, was that correct? No, this is the abstraction hierarchy. So it's the implementation hierarchy. Yeah, okay. Okay, that makes sense. Okay. Okay, so these instructions then, on how we get to this from the bridge pattern, there are instructions on how to do that in the actual textbooks. Okay, so it's worthwhile having a look at that. Okay, remember the bridge is a design that you can use to implement solutions like adapter. It's not like adapter, which works with the already existing or created classes. So always follow the instructions. So look at the pattern, look at how it decides to work, and then you can work through and get a solution. As I've done here, and this is before I've written any code, okay? But when you use the bridge pattern, it adds these additional entities, okay, to your code base, but it might not be appropriate when you use in certain projects where we've only one shape and two colors. So you could say, you could go back up here, let's say, yeah, there were 4 here, okay? So I ended up with 4 separate classes. And then here I ended up with 4 classes as well, okay? But actually, ultimately, you know, if we had squares and circles and different colors, sorry, if we had square, circles, triangles, rectangles, and we had lots of different colors, then, you know, the number of classes would certainly be reduced. Okay, so this is a better way to design than we had done previously, or could have done previously. Okay, so I have a demo here. Let me just check where it happens. Okay, so yeah, we'll get to demo in a second. So we could implement the language, of course, in any language, Java or C#. So what will happen is that we'll change some of the earlier shapes demo examples by refactoring our code based on the design principles, where we prefer composition over inheritance. So this is our design principle that we're going to use, okay? And so that means you can look at your code and you can decide, well, this was my design principle here. So if you're asked to look at your code or you're asked to explain your code and why you've done it a particular way, you can say that you had preferred composition over inheritance if you've done it this way and utilized the bridge. And that was really because we had to subclass many times in ways that were orthogonal to one another. So that meant we could end up with too many classes. So it also works for styles, okay? As I said, rounded shapes, in addition to colored shapes. This demo that I'm going to look at now just works with colors, but you could apply it to general styles yourself if you wish. So let me switch then to VS Code, and then let me just actually go down here. And you can see that I also have written this code for you. We looked at it after last time. I also have my bridge here. So we can look at the code and let's have a look at that window here. So this is not a long program. You can see it's quite short. You know, it really does the work in a very succinct and short way. Again, so it's my bridge. I have a public interface, which is color. And all I'm doing is I'm implementing this, okay? I'm just implementing this, nothing else. I mean, I guess, that's the point of having the UML, right? You know, it tells us about, you know, and gives us an idea of how to implement the design. This is the design for our code, so we got to use this, okay? So yeah, it shouldn't come as a surprise. I have this interface for color, and so I'm implementing this blue color, which extends color, and I have a method here that needs to be implemented in the subclass or the refined class, you know, or the concrete class. I'm just saying that I have a method here that shows the shape color here, and color is blue, okay, because it's blue. I have a public red color, so I have the color red. It's no different, really. It just does the red thing. Now I have an abstract class. Now, last time, okay, so this side of the bridge, okay, the implementer side of the bridge, I'm using interface here, and we're extending the interface. On the abstraction side of the bridge, the left-hand side of the bridge, I'm using actually abstract classes. So we go back here. This is an interface, and this is an abstract class. Okay, but we could go back, and if we go back through some of the, examples here. Yeah, we're using an interface here. Look, so I'm actually building it and doing what they're saying here. And this is an abstraction, so it would be an abstract class, but you may see some examples here where I'm using an abstract class, which is what I'm doing. I just haven't put the abstract in front of it. And you could use an abstract class here as well for the implementer, but I'm using an interface in this particular one. Okay. Okay, so that's nice to be able to do this. So let's go back to the code. Okay. So here I have my shape abstract class, and it has this protected color field here. And then I'm able to have a constructor here, which takes a color. You'll notice there's no arguments shape. So every time we create a shape, we have to have a color associated with it. Okay, and then we have a method called draw, and we expect our subclasses or our concrete classes, refined classes from here to implement draw as well. Okay, so we have a shape here, square shape, and again we have a constructor here for this particular shape. It's square. Okay, and what this particular constructor does is it passes on it calls the constructor from the base class. So it calls this one and sets this protected field here to be the color that's passed. And the color here, excuse me, it's not a string, it's an actual object. And we just draw, we say we're drawing the square, and you could use some SVG, for example. You could have something for the class where you have a way of writing out the information that's there, and you could use the color and so forth. We just show the color. But we could actually have a method that takes the color and then uses that color in terms of the drawing. We could have done this first. We could have another method like get shape color, for example, and then we could use this in order to be able to generate some string that we want to print instead of just say drawing the square. Okay. Now we have a client class, and that just creates a red square with a red color and a blue square with a blue color. You'll notice that we can't do something like this. Okay, we can't do this, doesn't allow us because there's no argument giving. We needed to have a colors associated with. So, you know, if you were creating something with styles, you would have to have a default style, some new default style or something. So we can't do this, which is not surprising. Okay, then we can just draw the red square, draw the blue square, and we just wait. So let's okay, and we can see that we're drawing the red square, we're drawing the blue square. Okay. And that's it really, that's our bridge. And we essentially just implemented this. Okay. So it's fine to do this. So in terms of the advantages of the bridge pattern then, so it improves the scalability of our code. So we can add new functionality without affecting other parts of the application. It reduces the number of subclasses when the number of entities would otherwise be based on combinations of two concepts, for example, shape and color. It doesn't look like it when we're just looking at two shapes and two colors, but believe me, it does work. You can do the numbers yourself, of course. Furthermore, it facilitates separately working on different hierarchies, so we could work on the abstraction, or we could work on the implementation by different developers, perhaps, allowing each developer to make the changes independently. It reduces the coupling between the classes. The only place where the classes are coupled is the bridge, which would have been the color field in the color abstraction that we saw earlier, the example that I did. What about disadvantages? Well, depending on the specific context and overall structure of a project, it could negatively impact on an application's performance. In other words, you might have to start initializing more objects and so forth, and that might be just detrimental. It might make the code less readable because it would be necessary to switch between the bridge and the different classes. So, you know, you're working on both sides of the bridge, you can't see everything straightforwardly. You can use an abstract factory together with bridge. And the pairing is really useful when some abstractions defined by bridge can only work with specific implementations. In this case, the abstract factory can encapsulate the relations that hide the complexity from the client code. So, you know, we in the earlier lectures looked at how we might use abstract factories to generate shapes. So now you could use an abstract factory to generate your shape and then utilize the bridge in order to be able to generate some color or style. Let's think about this pattern in terms of the open and close principle. You can introduce new abstractions and implementations independently from each other. Okay. That's nice. Yeah, so it meets this principle. In terms of the single responsibility principle, you can focus on high-level logic in the abstraction and platform details in the implementation. So that's really nice. So, you know, you're taking dual responsibility and you're splitting it. So you have two sets of single responsibility. So that makes it really nice as well. Okay, so the bridge then, it decouples an abstraction from its implementation, so the two can vary independently, and it's often used for implementing platform independence features, for example. Bridge adds one more method level redirection to achieve the objective, and the key approach is to publish the abstraction interface in a separate inheritance hierarchy, and then put the implementations into its own inheritance hierarchy. And you saw that we looked at, you know, the inheritance hierarchy. You can do whatever is appropriate. Sometimes you might use interfaces, sometimes you use abstract classes. So you can use the bridge pattern for runtime binding of the implementation and to map our token class hierarchies, as we've seen. And the bridge is designed in advance of the coding, you saw, or design. It means that the abstraction and the implementation vary independently. Bridge, state, and strategy patterns all have very similar structures, actually. So if you look through the book, through the websites, you'll see that they have very similar structures. They're all based on composition. And that's delegating work to other objects. But they all solve different problems, okay? But you need to understand the problem and then understand the solution. So check the other structural patterns, please, as part of your own revision study. And we can't do all of them. We don't have time to do all of them. But you can use this approach to do this. Look at the pattern, try to understand when you use the pattern. Look at the UML description, implement the UML description. Look at it as an alternative. Look at trying to generate some code from the UML, either in Java or C#, whatever works for you. And that would be the way to do this. Right, so we learned about the Gang of 4 structural software design patterns over the last 2 lectures. We saw adapter before, and today we were introduced to bridge pattern, and we saw an example of how you might implement that using C#. Thank you very much for attending CS264 Lecture 20.